Anybody get any questions before we get started back up? We'll give some people still out. We'll give them a few minutes to filter back in. Anybody? Any kind of relational engine problem you're having or whatnot? A couple of minutes of free consulting time here. Come on. Usually if one person asks a question, then there'll be like a flood, so somebody want to ask a question. All right, well, let's see. We'll ask this question then. Cost threshold for parallelism set to 0. What happens in your server? Why is it really bad? It's probably the single worst setting mistake I've ever seen. And I've seen some doozies.
Force parallelism?
Doesn't force it. But the cost threshold for parallelism determines whether or not the optimizer is going to bother evaluating parallel plans. Okay? And it's all cost-based, not unitless math, right? And every operation that the engine has at its disposal has some value per something, usually per row, right? Like an index seek is 1.632905 or whatever. Joe Chang did some math way back when, right? So if you set the cost threshold for parallelism to 0, any non-trivial plan has a cost greater than 0. So the engine can say, well, let's see if a parallel plan is going to be more efficient for that plan that does an index seek for one row, and the cost is 0.00160955, whatever. And it will waste CPU, RAM, locks, latches, stuff to come up with a plan that probably isn't any faster, but it had the cost to do that. It took time and work. And I first got to this client. That first thing, I have a laundry list of things I do for like a health check or, whatever. And wow, I'd never seen, if I see something that I've never seen anywhere else before, it's bad for you, right? So I said, really? And then I went and looked at the CPUs and they're like, bzzz, on all their servers. So I took their production DBA, who happened to be an ex-Oracle DBA. I said, come here, I want to show you something. So we remoted into a production server. I said, watch this. She's like, you're not going to change that value, it's a production. It's like, you can fire me, I'll give you $10,000 if it screws up your system. So we changed it from 0 to 15. And the CPU did a step change, right? Because it stopped wasting time looking for parallel plans that were more efficient than that little thing. Okay? So that's one. The other one, beware SSDs. If we have time at the end, I'll tell you a tale of why bigger hardware can totally hose you up. So, and a lot of people are probably thinking about, we need SSDs. Because remember that other page that said that rotating thing was why your stuff was slow? Yeah, SSDs, watch out. And it isn't because you burned through the life. That's old stuff, doesn't count anymore. So you've seen this before, blah, 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 blah. This is an old deck. I didn't update the world class thingy. I totally rock. I'm not good at SSAS. Awesome platform. We've been through that, right? I said that last time. It's really true, right? It's totally awesome. But if you do things right, I mean, I told you a bunch of things you can probably take back and, right, start making things go better. Okay. So let's take a look. We got, see what time it is. All right, it's 1:04 p.m. my time. Thankfully, I'm not asleep right now. I'm going to give you till 1:06 p.m. Think of anything you can think of that's a bad setting, that's default. Go. I'll start you out. Optimize what? Well, that's not a default. That's your fault. Or actually, it's the guy that bought the server. It's the chief technology officer's fault.
Max server memory.
Server memory, max. 1 minute. I'm US. I don't care about that stuff. La 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 la. If it's not default, don't call me.
Update stats asynchronous.
Async.
Auto close.
Oh. Drop and give me 20. What's that?
That's not
You remember yeah, it's not defaulted on, but if you have it on, remember Paul Randall kills a kitten every time somebody turns that on? I've seen it happen. It's not pretty. I think he does it in a sheep costume too. You still got maybe 20 seconds. File size. Ooh, file size. Actually, there's one that's worse than file size. Ha! There we go. We got it before. Ah, there you go. Just under the wire. That one's really bad. One of the worst ones. All right, so let's see how we did. Oh, I went up, down, blah, blah, blah. 2 minutes. Disk configuration. Right? If you screw this up, how do you fix it? Bare metal. And that's probably not a good thing for you guys. Okay? Sector alignment. It really matters. If you're not sector aligned, pure 64K random I/O, 50% loss of performance and throughput. 50% by not sector aligned. Now, new OSs since Windows 2008, if you build volumes that are greater than 4 gigabytes, which they're not all greater than 4 gigabytes, right? It will sector align by default. However, what about the 2 or 3 OEM or Windows partitions that get chunked in the first part of the disk before you even install the OS? Do they sector align? And if they're not sector aligned, do they make everything else sector align? I don't actually know the answer to that, right? But if you don't, it really, you 50% I/O loss for pure 64K random I/O if you're not sector aligned. It really does matter. 64K NTFS cluster size. Remember what I said about next, default, everything? Well, the Windows part of that is building a volume and formatting it with default, which is usually 4K, which is way too small. That's not, like 50% performance improvement, but it is a few percent. And of such small things is big performance gains achieved on a server. Okay?
One more on this, actually, of the defaults, I think, is to put everything on C, isn't it?
Everything on the C, if you do next, it puts it in your boot partition, right? However, we'll talk about those partitions in a moment because there's a lot of things you can do with that, right? Power config, magic bullet. Default is what? Balanced. It's a 4-letter word. You want it high power. If it isn't that, change it immediately.
Sometimes have to change it in the BIOS as well.
BIOS, virtual machine, host, and the guest, but the host actually is the one that really matters, right? BIOS, check them all. This is double-digit performance improvements on servers that are under load. People refactor things to get 3% improvement sometimes. This is a guaranteed magic bullet. And all you got to do is click a button and say OK, right? Go look in the other advanced options. A lot of things can be turned off and slowed down because of power things. I don't know exactly all of what high power does on every version of Windows that's out there. Check them, because you may not want it to be able to turn off some of your NICs or something, right? BIOS, UEFI, okay, could be power things in there, right? Green is not what you want your SQL Server. You want it red hot, go bang fast, okay? Remote dedicated administrator connection. That's your back door. It's guaranteed a slice. And when the fit hits the shan, is not one we want to be pulling out books online going, how do I get into the dedicated ad? Because the server's locked out because somebody ate all the connections. That in hibernate thing got out of control. La, 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 la. Okay, you want to set it up. Make sure that you can access it not on the server, because default means you have to be on the server. Well, guess what? If the server's eaten and you can't remote into it, you better have remote access enabled. And you better know how to get to it when you need to go find out why the server's not responding. Nobody can connect, so you can kill the bad thing and release the stuff, right? It's a big deal. You read books online before the bad stuff happens. You don't want to be flopping and twitching when Ericsson is calling you about why your product is not being served up to the 30,000 people that are trying to use it right now. Okay? It is like insurance. We don't want to have to use it, but if we need it, we darn well hope it's giving us our little slice of the pie.
I think also some things are only available when you use the DAC.
And some things are, and some things aren't. Like I said, read books online, find out what you can do and what you can't. And don't run your critical work, data warehouse workload on it. So, database mail is not enabled or configured. So when your stuff fails, you don't know it. When you throw a bunch of error 824s, which are bad, right? Anybody know what an 824 is?
Corruption.
I/O corruption. You want to know that the millisecond it happens so you can start doing things to make it not cause problems because you didn't detect it for 3 months. And now you don't have any backups that aren't corrupt. Okay? Enable it. Set up alerts for error severity 17 and greater. Set up alerts for 8, 23, 24, and 25. And anything else that you might find from blog posts or other advice. Set a SQL Server agent fail-safe. So if you have pager cycles and all that stuff, big companies, a lot of people have that, somebody always gets notified. Okay? Questions? Pretty easy. Backup compression. Use it. It saves, unless you're already CPU bound, then the CPU ticks may be more important to you than the savings in CPU. Often in modern hardware, that's only if you're virtualized improperly. Then you can become CPU, have trouble with the sufficient CPU, right? Third-party tools also offer, right? This is one of those things that I was actually upset that Microsoft bothered to put in the engine. Because Microsoft is the only one that can modify the source code of SQL Server, all of it, right? So anything they put in there is stuff that only they can do. Well, guess what? When they put backup compression in the engine, there were already at least 4 viable third-party products. They'd wasted manpower doing something that there was already plenty of ecosystem for, instead of building stuff that made the engine better, or analysis service better, or RS, or AS, or Azure, God forbid, right? There's no maintenance. Every client I ever have is essentially mandated that they will use this. It's free, it's fully documented. Ola is a really great guy. It's always voted 1 or 2nd best of the 3 things available for SQL Server. The other one is what? SP who is active. Everybody know that? If you don't, okay, let's write this down. Add Mechanic has about, I don't know, 700, 8,000 man hours in that one stored procedure. It's free, self-documented. He's got a 30-day blog post series on SQLug.se. Amazing functionality to tell you what's going on your server right now. Use it. Ola Hallengren, free, fully documented, great developer support. You tell him there's a bug, he will fix it. It builds jobs for you in SQL Agent. All you have to do is schedule them, configure them. It's configurable up one side and down the other, right? Always on, it knows about it. It will back up wherever you say it should back up. It's really just amazing. And it does all of it. Backup, statistics, index defrags, and check DBs. It'll log into tables, to files. You can parse them. Say, wow, I keep defragging this stupid index every night. What should you do? Change the fill factor. Don't page split it throughout the day, every single day. Fill factor, fill factor, fill factor. No maintenance plans. Database size and growth increments. Devastatingly bad. Okay? 1 megabyte growth. So, back to this guy. So your 1 terabyte data warehouse started out as a 4 megabyte database. and you put a terabyte of stuff in it. This looks like a 16-year-old boy's face. Mine did. Right? So let's see here. Let's do the math. A terabyte is 1,000 gigabytes, which is 1,000 megabytes. So you have 1 million 1 megabyte pieces on your disk or disks. It doesn't matter how many disks you have. If you have 1,000 disk 3-par system serving up your data warehouse, you have 1,000 fragments on each one of those disks. Remember, sequential I/O is the best you get out of rotating media. You have 1,000 fragments on there, you're not doing sequential I/O anymore. It's all random. Everything is random. Bounce, spin, bounce, spin, bounce, spin, bounce, spin. And if you're lucky, that's like 10, 15 milliseconds. If you're like most of my clients, it's like 150 or 600, or you have warnings in your error log that say, what? Your server has taken 3,282 occurrences of 15 seconds for I/O. Anybody admit to having those in their log? Okay, it's just devastatingly bad. So what do? You back up, you check DB, you make 3 copies of backups, you verify them, you restore them somewhere, you shut down SQL Server, you defrag your hard drive, you bring it back up, you do a couple more check DBs, and then you turn it over and you're good to go. Or you detach it and reattach it, remove it, back it up and restore it, whatever. Get rid of those guys all over the disk. And it will I've seen over 25% throughput in I/O performance just from defrag. Log starts out 10% growth, VLFs, virtual log files, Kimberly Tripp, that's her thing, right? She's good at blog posts on what they are, how to size them, all that stuff, right? And think about the fact that you've worked your way up to a 72 gigabyte transaction log in your data warehouse. What happens when it grows? 10%, 7.2 gigabytes. What happens to a log file when you add it in SQL Server? What does the OS do to it before it gives it to you? It zeroes it out. So it takes every bit of every byte of a 7.2 gigabyte file and it writes zeros to them before it says, okay, you can play with this now. Meanwhile, what does your SQL Server for that database do? Nothing, other than read-only, or with no lock selects. Right? So go look for that. If you got big chunks and big growths, you may be causing slowness, right? Because the transaction log always gets zeroed. Okay? Defrag or backdrop it and restore it. That will flush it out. But if you have other stuff on there too, if you just drop that database and restore it back and you got 6 other databases on there and they all grew by 1 meg, you have a bunch of holes in there, you just put it back into the holes. If you don't defrag the drive, you didn't do anything for yourself other than have an outage. Okay? Auto growth. Do not ever manage your databases with auto growth. Period. Proactive. 18 months, how big am I going to be given what I project is going to happen? Data and indexes, make it that big now. Free space is great because if I have free space, when I do index maintenance, I get sequential space on the file. That's sequential I/O. That's as good as I'm going to get from the rotating media. And Jonathan Cajeas actually did testing. Random I/O is actually slower, measurably slower in solid state. Not like it is in rotating, but it's still down in the percentage point kind of thing that could make a difference for your queries. Okay, Kimberly Tripp, log, VLFs, all that stuff. TempDB, nobody mentioned that. That's like next to that thing is why your thing is slow, right? TempDB, always a problem. That is just crazy old advice, right? When that came out, 2 cores was a big server, right? Now you can get a CPU that's got, what, 20, 15, 16, something like that. Cores per CPU. 1 file per 4 physical cores, maybe limited to 8, all right? And what are we looking for? There's 2 reasons why we would change our TempDB configuration. One of them is because we have a lot of disks and multiple files doing async writes or reads can be faster. Or we put them on separate disk subsystems, even faster. What's the other reason that we might change the files at TempDB? Allocation, latch contention. So every time you create a temp object, whether you do or the system does it for you, there's a latch put on a PFS, page free space, or an SGAM, I can't remember what that stands for, that's in each file that says, I'm going to put an object over yonder in this 4 GB run of space in this file, right? Bitmapped thingy, right? So that latch of that PFS or SGAM becomes the hotspot in TempDB if you build a lot. You know, if you're Amazon.com kind of frequency here, you get PFS or SGAM latching contention. Multiple files allows you to mitigate that problem, as does some trace flag manipulation and other things if you see that. And the SP who is active, if you do it and you see the wait type as latch 2:1:1, 2 is TempDB, 1 is a file, and 1 is the PFS page, that's saying that you right now, that thing is waiting to get a latch on the PFS page in TempDB, and you can address that with the trace flag and having multiple files per TempDB. Okay, but just like having a million files on this thing is going to cause random I/O and make it be slow, if you put 64 files on TempDB on your 4-disk RAID 10, you just created random I/O slowness because you have too many files. TempDB is round robin usage, so when you put an object in there, it's going to hit 64, and when you read it out, it's going to hit 64 files. That's basically random I/O all over the disks. Too many files, too many partitions is bad for rotating media performance. Okay? Size it equally, identical growth, or just make it as big as the volume is. If you got 50 gig for TempDB stuff, make it 50 gig. If it's going to grow bigger than that, it's going to blow up anyway. Right? So it can't hurt to just make it that big. MSDB indexing, there is none. And if you don't flush out old backups in job history, but especially backups, you can crush a server's performance by simply trying to find out what the backups were. And automated tools will do that. And I've seen them bring a server to its knees. I've seen simple backup jobs run every half hour, take up to almost 20 minutes, just table scanning TempDB's backup and restore tables. Meanwhile, the server lost a whole core and all the I/O and all the buffer pages simply reading MSDB tables over and over and over again because they're not indexed. Well, one, you shouldn't have 2.3 million rows in your backup history tables. That was problem number one. The other is if it was indexed, it could seek the things it was looking for and be much faster. Okay? Get rid of the old stuff. Because if you don't have the files right there on the disk that you stored them in anyway initially, backup history doesn't do any good because you can't use the GUI because the file isn't there. Once the file's moved to some other location, it's no longer useful to have it in backup history because you can't do a GUI restore, which you should never do anyway. But Jeff Heighton, way back when, 2008, wrote a little blog post that has some indexes that will help you. Okay? But the key thing is flush the history. Don't let it get to be 2.2 million rows. Call trace over parallelism. 5 is universally too low. It really is. Right? Servers have way too much parallelism now. The CPU cores are more powerful than a collection of servers were just 5 years ago. Okay? No hard and fast rule. I typically do this if I have no other information. I always have other information though. Right? But watch for too much parallelism, watch for not enough. And if you really need parallelism, what can you do? There's other things. Adam Mechanic, Paul White, there's some query trace on, some neat flags, 9648 or something. You can actually do a what if and change the cost of the engine's parameters. If you really need it, you can get in there and play under the covers. Right? But be careful. We talked about CTFP equal to 0. We did mention this one on our list, right? Max p of the degree of parallelism. 0 is universally not the right answer. Right? But if you need 0, what can you do in your query? option, parentheses, max DOP, whatever number you want to put there. And sometimes you want a report that uses all 64 cores, right? The problem is that every server you buy now, and even a lot of virtual machines that you make now, are NUMA machines, non-uniform memory access, right? Because they found out with symmetric multiprocessing that this pile of servers here going to all that RAM was slow. It was just too much, right? So they decided to carve it up and say, this set of CPUs gets this block of RAM, and this set of CPUs gets this block of RAM, and I'm going to be really fast if I hit my RAM, and I got to go around my elbow to get over to the other side, and it makes it slower, right? It's called non-local memory access. And when you do that, it's much slower than local access. So you don't want your parallelism to be greater than the physical cores on your NUMA node, not the hyper-threaded core count. Because if you do, you're almost guaranteeing that the memory and the RAM and the CPUs are going to be doing that. And anytime it does that, it's slow. Okay? So take a look at that in your systems, especially reporting type systems, to see if that can help you out. All right. And if you do have big queries that need to get all the resources, you can do that with option hints in the option max DOP. Max server memory, we hit that one, right? The default is integer limit to 0.12 terabytes, which is a lot. Too much, SQL Server will take too much. And it will cause the OS to page and have lots of problems. That's it. No server, even development servers, even your laptop server, they always have a max memory set. You've got to reserve stuff for everything else. And everything else depends on how much stuff is running on it, right? On your laptop,
If you have like more than one
instance of SQL Server, right? And then you have failovers, right? And you got an active cluster, and when they fail over together and they're both set at default, now they're contending and paging, and neither one of them is doing well. Set your limits. If you have a cluster and you have active, set it to trigger when a failover occurs to automatically adjust both of them's max memory to keep them from contending with each other. Lots of things that you need to think of to get optimal performance. Okay? And there are various formulas, 5 gigs, 2 gig for the OS per 4 gigabytes of total. There's lots of stuff. But it can't ever be the top or close to what the memory in the server is. Okay? Lock pages in memory. It's usually a really good thing until it's not, and then it can literally cause your server to stop functioning, which is a bad thing. Okay? But it is good to not have SQL Server's memory forced to reduce. This really comes into play also when you have virtual machines. Now you got ballooning and reservations and other things that can get in the way also. You just compound the complexities when you introduce virtualism of any flavor, Xen, Hyper-V, or VMware. Okay. Optimize for ad hoc workloads, we hit that one. Okay. It's usually a really good thing. Single plans, remember when they come in first time, checks to see, do we have it? No. Okay, I'm going to build a new one and put it in the cache. And it's this big honking ORM thing that gets called exactly one time. Why? Because it's all string-based variables, precise, exact, dynamic SQL, and it hashes all that text, and if the hash isn't equal to the next one that comes in because it's Smith-son instead of Smith-sin, now it's a whole new query plan, right? So you have a 1.2 megabyte query plan, that's a lot of RAM, you just lost for one execution. It's never going to get called again, and that's a bad thing. So optimize for ad hoc workloads will generate a hash of the query plan, which might be 1,762 bytes instead of 1.2 megabytes. And it will store that in the plan cache. And the next time it gets called, every other query that comes in, it makes a plan, it hashes it, it checks to see if the hash exists. If the hash exists, it says, oh, this is the second time you've called that same one. If it's 2 or more, I think it's going to be more than 2, so I'm going to go ahead and store the whole 1.2 megabyte plan. Okay? So this can save you a lot of RAM in your cache, which is stolen from the buffer pool, which is data, which is what you really want your RAM to be doing, right? So the bad thing is that sometimes you can get a lot of the little hash guys in there, and now your performance can go south because the lookup of the hash table can be slow. So there's not always a right answer here. Okay? On some systems like heavy ORMs, right, that aren't doing parameterized stuff, which is bad, or old systems that do SP cursor things, right? I had an old ADO Classic system. I flushed the plan cache on with a sledgehammer every 15 minutes because it would just fill it up and I'd blow it away, and it'd put more stuff in memory and it would steal some pages and I'd blow it away. And I'm trying to do a balance. CPUs, I had plenty. Compilation, I didn't have compilation locks. What I did need was to stop hitting my rotating disk, and that meant keeping the buffer pool full of data instead of full of plants. So you can flush it with a DBCC, free proc cache, or free system cache. There's a couple of different things you can do there. Okay? There's a blog post on the effect of optimize for ad hoc workloads. I think that one's Paul Randall. IFI, instant file initialization, magic bullet, right? Especially if you let autogrowth manage your files. Right? So remember what I said about when you create that 7.2 gigabyte log file, it zeroes every bit of every byte of the growth. Or when you restore your 1 terabyte production system on your QA system or your laptop, if you don't have IFI on, it will zero every bit of every byte of the 1 point whatever terabyte data stuff before it puts the write down. Right? It just kills you. Right? Absolutely kills you. With instant file initialization, you tell Windows, just give me the darn file. I don't care about the stuff that's already in the physical disk space where you're going to allocate my 1.2 terabytes. Just give it here. I'm going to manage it. And when something needs to be cleaned out or overwritten, I'll take care of it. That is a security flaw, which is why it's not enabled by default. Because if somebody goes in with a disk editor and opens up that file, they can see stuff that used to be in that file space. I submit to you that if someone has a hex editor open on your SQL Server, you're already owned. Right? You got bigger problems. So it really is a massive write on the disk. IFI says give it back. And you go to the restores also. So production or QA to dev all can be slow because you don't have that on. And it is via SE managed volume name, which is a group policy for the login that's used for SQL Server. If you have SQL Server logged in as system or network, whatever that thing is, then you already get it, because local system is admin on that local box. But we don't do that, right? Always have dedicated accounts, especially for production systems that have only the rights that they need to do. And you want to set that. Okay? Transaction logs are always zeroed. There's reasons for recoverability that the zeros have to be there so it knows in a disaster where the end of the last stuff that was physically written to the file is. Okay? So you can't fix those. So that 10%, 72 gig, you're still going to get hosed. Trace flags, you really want 3226 on. That says don't gum up the error log with I backed up a database successfully messages. And if you have a lot of databases and you do frequent backups, there can be millions of little I backed up a database log or whatever in your error log. And then when you need to go look for an error that happened, you got to sift through all the stuff or know how to filter properly to see what you really want to see. Right? Plus, this is writing to a disk where the logs are. Right? So definitely want to get rid of that one. 1118, no mixed extents. That was done back when 8K pages, that's an extent, was a lot of space, 64K, when they first made this. Right, so put the trace flag on. Now, if you build an object, it gets 64K, period. If you have a problem with that, then I think you need bigger disks or whatever, right? If 64K is a problem. Lock pages in memory on standard edition. We yelled at Microsoft a long time to get them to enable this, and they finally did. It used to be an enterprise-only feature. And now you can enable it on standard edition with a trace flag. 2371. What I said about the 800-pound gorilla client. In this case, it was SAP that that said to Microsoft, we're getting killed by this. Fix it. Microsoft said, yes, sir. And they put trace flag 2371, which says on large tables, we will not update statistics at, what's the percentage? How many rows do you have to modify in a large table before AutoStats will fire and update the statistic? 20% plus 500 rows, right? To be really technical about it. So if you have a 200 million row OLTP table that's just getting creamed every day because you're a big SAP user, you could go weeks before you modify 20% plus 500 rows of that 200 million row transactional, we got to know what's in there right now. And if you got to go weeks before the optimizer knows that there's 2 weeks worth of new data in there, your stats are going to be out of date, not representing reality, and you're going to get bad plans and performance is going to be horrible. So 2371, it actually has, the MSDN blog post has SAP in the name, right? But everybody gets the benefit. There's a lot of stuff out there that we benefit, like MySpace. A lot of the stuff that's in Service Broker, direct result of MySpace. And Service Broker is really cool. There's some amazing, they used to pass around, 15 years ago, they used to pass around hundreds of millions of SSB messages a day. And the stuff that's in there, all the bug fixes and the scalability and what it can do, directly from MySpace. So but 2371 says, use a descending scale of percent of rows modified the more rows you have. And if you hit, you got a 200 million row table, you might have to modify 2.3% of the rows. And then AutoStats will fire for you. But you probably should be doing your own statistics management on your most important tables, right? AutoStats is lazy man's stuff, right? Do your statistics for the right reason. And you might need to update it every hour on some tables, right? Because it's that important to know the stuff that's in there right now, or the stuff that's not in there because it got flushed. 4199, there is a butt ton of optimization enhancements that are not enabled unless you put on the specific trace flag for each one of them, or 4199, which is a bucket back in 2005, under which Connor Cunningham decided, we got so many of these, we don't want to have them enable all these things individually. So we're going to create 4199, and any past ones that we choose and any new ones that we choose, we will activate all of them if you simply put on 4199. And go look at the list. There's a link in here for that. It's really amazing, some of the stuff that you don't get unless you put 4199 on. It's really, almost everyone in this room should have it on all their systems, right? But test it, because if your one query goes south when you put it on, you just killed yourself, right? And then most systems have like that one query that really runs all the time, and it's got to be really fast. But if 4199 makes it run 60% faster, or even 10%, it could be a big win, right? Lots of stuff there. Antivirus. If it's on your server, you better be excluding a whole bunch of stuff, or you're just burning CPUs for nothing. And RAM, and I/O, triple whammy, right? Patch. Almost all corruptions that occur in SQL Server are because of firmware or drivers, or both, right? If you implement new hardware, nobody touches it until all the firmware, the BIOS, and all the Windows driver, everything is up to the latest, unless the latest was less than, say, a week ago. If you do the stuff that just came out, you get what you deserve. You better scan the forums to find out, oh, look, that service pack causes an infinite loop in the installer that blows up your registry and your server crashes when it hits 2 gigabytes. That happened in a Microsoft Service Pack not too long ago. So don't put out the latest thing. Wait a week. Look to see if anybody's had any really bad problems. Right? Service Pack 2 for 2012 had a bug. You could do a clustered index. Rebuild, I think it was, online, and you could lose data. Right? That's bad. So don't do the really hot off the press. But everything else, test it and put it out there. Because the waiting for service packs, you can't do that anymore. The old model is gone. You're never going to see that again. If you don't do the CUs, the cumulative updates, go read what some of the bugs that they fix in there. There's bad data all over the place. There's all kinds of performance problems. You got to do the CUs. Okay? Windows updates, SQL Server, SPU is active. There it is. Learn how to use it. Anybody in here does anything with the relational engine. Developer, admin, got to have it. Performance dashboard, free stuff. It's like a third-party monitoring tool that is freely available, just works off reporting services. Neat stuff. Q&A? Anybody? A lot of stuff in a short period of time. Let's see how we did. Cost threshold for parallelism, yep. Fill factor, yep. Ad hoc, max stop, mem. Well, that doesn't exist. Async stats update. There's a bug in one of the things. If you don't update to a CU, you have a memory leak, and it'll bring your server down. Okay. It's really cool, though, because you can have query plans still run with what it is and not get blocked by the act of doing the statistics and the flush of the plans and all. And then it just kind of bolts it in after it's done. Really neat. Enterprise only, so you got to pony up the 4x per core. Sometimes you got to do what you got to do. Auto close, just don't do that, right? I had a client with 7,400 databases on one server.
But that's the default.
Okay. The default, auto close is not on by default.
So that's good.
Yes, it is good that it's not on. Do not ever put it on. There's a lot of bad things that happen from that. Auto shrink.
The thing is with the auto close is that's on default on Express. So if you restore databases from Express, you get that setting with you. And I've seen that on one time as well with a
Didn't know that. Okay, so the auto close is on by default on Express, and apparently that gets carried when you back it over to production. It makes me a little twitchy just hearing that and saying it. I think I might have to, you know, rinse out with soap or something, right? So, file size and file growth. So we did pretty good in our 2 minutes, right? So, kudos. Anybody else? Anything?
Shrink.
Shrink.
New version, it's okay.
What's that?
The latest version, it's okay already.
It's okay to shrink? It's never okay to shrink. Well, that's not true. Shrink file. Okay, what happens in shrink file is, think of your internal SQL Server stuff. It winds up like this. Now, it will be like contiguous, but this is table A, and that's table B, and that's C, and they're all interspersed. So now, internally, all your stuff is random. And if you do DBCC, or not showcontig, sys, index, physical, stats, right? Detailed, you'll see like 99.638% fragmentation on all your stuff when you do a shrink of a data file. So if you're going to shrink because somebody messed up and did a Cartesian insert and you put in 100 billion rows instead of 10,000 rows, well, then you have to do a cleanup evolution, right? So, but when you shrink it and then you make it bigger, 12 to 18 months, and then you defrag everything full. I mean, rebuild, not reorg. Rebuild everything. And then you do a DBCC and a backup and restore and make sure it works, and then you have a golden copy of the database to use again. Okay. Shrinks are bad. Really, 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 really bad.
They improved something.
They improved into shrink. Nothing to my knowledge has been changed in the shrink.
In 2014,
Send me an email on whatever link you think says that it's changed, and
I mean, it's not cool.
we'll
It's not perfect, but it's better.
send me something and we'll figure it out. And if it is, I'll put something that he can put up.
Trace flag that you can turn on to sort of disable ghost cleanup during shrinks.
Ghost record cleanups.
Little bit
Yeah.
faster, but
There's some other things. Yeah, ghost records are kind of weird anyway. But if you have heap tables, you probably want to not have heap tables. That's where ghost records come from in the first place. I've seen one-row tables that are multi-gigabyte in size because the pages don't get deallocated when you delete them around. Yes, question?
Yeah, I've seen something about the SSD disks, especially for SQL 14, that they would put the 10 TB on the SSD disk, so it's local. You don't need to use the sound to get the source.
Yeah.
You had something to say.
Temp DBs get a lot of activity, especially if you have triggers, which go to TempDB now instead of doing table scan or transaction log scans, which they did in 2000 and before. So triggers can cause problems. Snapshot type isolations really can crush TempDB. CheckDB can crush TempDB. Right? Lots and things. Hash sorts, group bys, all that stuff. So, I mean, I've seen queries that where a client has 75% of all their queries have a sort in it. Because humans like to see when they're building and testing, they like order. And it can also make, checking that you have no gaps or the right data easier. When you roll it to production, if you don't need a sort, get rid of it. It's expensive operation. It's TempDB. It may fit in RAM, so you're wasting RAM to do a sort instead of storing buffer pages. But if it doesn't fit because it's a busy system, where's it going? TempDB, which is slow. Roundy, 180 milliseconds per, right? But, so in SSD land, one of the most common places what you use it initially is TempDB because it gets a lot of writes and a lot of activity on most systems because they don't have enough RAM, right? They don't have enough RAM. If your server isn't maxed out in RAM, that's the first thing you want to do when you get back to work. Get a requisition, max the RAM, okay? Unless your old database is less than RAM, then it might be okay, right? So, the thing is, clustering may be what you're talking about. It used to be, if you had a cluster, you have to have shared storage. Well, long ago, 2005 actually, there was a workaround that wasn't supported where you could cluster and have SSD local TempDBs, and it worked, even though Microsoft said we don't support it. And everybody that did clustering and really wanted a fast TempDB did that. So now you can actually do it, and you don't need, it is supported now to have a cluster, failover cluster instance, with local TempDB. Works fine. And Fusion.io, they love that, right? Because they make stuff go really fast. Right? So remember I had a thing here. Beware SSDs. Okay, so here we go. We have time for this? How much time do we have? I can't see how much time we have. 10 minutes. 10 minutes, okay. If anybody needs to go, just go ahead. So, nobody thinks that faster hardware can ever be a problem. So they just plan an outage, they back up their databases and they restore, or they do transaction log shipping, or they do mirroring to the new system, maybe with an upgrade of SQL Server at the same time, maybe not. And then they do a flip over and poof, everything's magically faster, right? So, client that had been with me for almost 7 years decided that they were going to implement solid state storage, and they didn't tell me, and because it's faster hardware and it can't ever be a problem. So they planned an outage, they backed them up, they restored them, they did internal testing, and then they opened the floodgates. And this was a company that is an auction company. And when they opened the floodgates, the system was instantly non-responsive. It was essentially non-functional. Because the web people come in, they knew when the outage ended, and they wanted to get their bids in. So think about, I love a whiteboard. I'm so glad we had this. So we have object A and object B. And we have query 1 and query 2. And query 1 says, I'm going to update that guy, and I'm going to read this guy. And most of you know what's coming, right? Query 2 says, well, I got to read that guy, and I'm going to update that guy. What do we have the potential for? Deadlock. So on the rotating thingy, all your queries were always doing page IO latch _sh wait types, or your file IO stalls were in the hundreds or thousands of milliseconds. And query 1 and Q2, they never bumped into each other Because this one says, oh, I'm waiting for I.O. Hey, I'm waiting too. How you doing over there? All right, I got my I.O. See you, I'm done. I'm still waiting. Cool. So this one finishes, and this one says, all right, I got no problem here. And because it didn't really take the lock until the resource got into memory, right? Nothing happens unless it's in memory. Well, you're waiting on I.O. So they never bump into each other. Maybe every now and then you had a, deadlock in your error log, and you didn't worry about it because, who cares if that transaction got rolled back anyway, right? So, but now you dropped in Fusion I.O. without testing. And now the waits for each I.O. went from 182 milliseconds to 0.7 milliseconds, which is it can do a lot, tens of thousands at that speed. And now this guy says, hey, I got my bang. It was a blizzard of deadlocks, right? It was instantly non-functional. And guess what? They didn't have a plan for how to get from there back to the old rotating system. And some activity had already happened. People had bid, things had closed, auctions were won and lost, and new stuff came. How do you get back? They had no plan. It was a bad call at 3-something in the morning to go, what do we do now? I was like, what? I didn't know you were doing anything. Yes. So, and I've seen it on the forums too. People get deadlock problems with SSDs. Logically, it just makes sense, right? They don't wait anymore for I.O.s. They bump into each other. Bad code, bad design, bad indexing. That's why you have deadlocks in the first place. But you don't want to go try to figure out why you have them and fix them at 3 o'clock in the morning after a production rollout.
Just put a lot of wait for in the code.
Wait for. La 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 la. But remember what I said, the right answer, here, take this business card. The right answer always comes before performance. Right? Test I don't care if you think that your $1 million server is just going to make everything better. Right? It may not cause deadlock blizzards, but it may uncover something else that you didn't know existed because your current hardware simply couldn't get you to the next brick wall that it's about to slam you into. Okay? Anybody else? Remember I said one person asks a question and the floodgates open. So
what happened?
What happened?
Yes.
They figured out they just shut the system back off. They read all their activity logs to find out who did what. They just went back to the old system as if they'd never went to that one, and they took basically lots of phone calls and trying to manipulate data to reflect what had happened during the time before they went, holy, before the brain, when something really bad happens, your brain, the adrenaline kicks in, and it's 3 in the morning anyway, so your brain's already fried. And the higher brain functions go when the adrenaline pops, right? If you literally think that truck's going to run you over right now, your higher brain function just goes. Used to be it was good because then you could fight the saber-toothed tiger that was about to jump on you, right? Or run away faster than he could. But in modern times, it's really bad when the higher brain function goes, right? But so you got to think of these things before the fit hits the shan, right? So it was a really big mess. And oh, did I yell at them, right? I really, really yelled at them.
Would you have been able to avoid that with unit testing?
Unit testing, no. Because the unit tests aren't at scale. They tested. They had like 12 people up doing orders and bids and placing new objects in the system. It worked fine. It was real. It was like, cool. Let's go. Right? Load. Unit testing doesn't tell you that your system's going to crash when you have 13,000 people this second trying to do something. If you don't build a system that does that for you, and it's kind of hard, but with distributed replay, it's much easier now, which is 2012 and above. You can actually take profiler traces, make a restore of the database, or back it up, crush the system with profilers to disk with certain configurations, back that up to another system, and replay that workload at a really fast speed. It's pretty cool. On multiple machines even. It's really neat. Okay? Or build your own system or buy third-party products. I'm sure they're still out there. So one thing I'll leave you with is every client I ever have are taught to do 3 things whenever there's a performance problem, when it first arises, without thought, before they do anything else. That's one. They run that in a Management Studio window with grid results. Now, something like that. Analysis. 3. N-A-L-Y-S-I-S. There we go. SP who is active will tell you what's happening right now. Look, I got 382 SPIDs blocked by that one thing. Go find out why and make it go away. Or you have 382 things blocked by 7 different SPIDs. This can show you the head blocker of all the things that each one of those 7 is blocking. They might not be the same one or the same query. Learn the options that this can do. Really amazingly powerful. File IO stalls analysis. Run in a window with text results out. This, every time SQL Server does a physical I/O, it starts a counter and it says, I'm asking for physical I/O because it is in the buffer pool. Go get it, Windows. Windows says, all right, I'm sending it out to the SAN. The SAN says, I can't get it for you yet because I'm running Exchange and Oracle on the same 4-disk RAID 10 that you're running your SQL Server. Okay, I'm coming back now. I'm in the memory buffer pool, page I/O latch goes away, and that is an I/O stall, only physical. But it's tracked since server uptime for every file in every database. And if you do a differential analysis, you take a snapshot in sys dm IO physical stats or something, you put it in a temp object, you wait for 3 minutes, you take another snapshot. Stuff happened, you diff them, you divide by 180. That's how many IOs happened and how long it took for each one of them. If you see TempDB is taking 593 milliseconds for the 14,282 writes that happened during that 180-second interval, go make TempDB faster or figure out why you're hashing and scanning all those things. Oh, I don't have an index on that one big fat table that I'm trying to get one row from. Right? Wait stats. Every time SQL Server says this query is ready to run, but you can't because you can't get something. A latch, memory, I/O, CPU ticks, or, well, CPU ticks doesn't count. The OS has to do something, preemptive something. It says you go in a little waiting pool and you're in a page I/O latch SH wait state. I'm going to track a counter. Every 4 milliseconds, all these things pop on and off the schedulers, and nope, you still don't have it. Nope, you still, okay, now it's available. That's a wait. Page I/O latch. And you can run now because the thing you were waiting for is available. Oh, guess what? You can't run because the schedulers are so busy because we're on a 2 virtual CPU VM and we're overloaded. So you can wait for CPU now. That's a signal wait. It tracks those too. So you can reset that with a dbcc command. But in any case, you want to take a snapshot, wait for some time. I tell my clients 3 minutes. Take it again, diff them. Oh, look, I am waiting on lock_m_x, exclusive locks, meaning for some reason I can't lock an object that I want to update. Oh, I'm missing an index, so I'm scanning that table and I'm shared locking it because I don't have with no lock. Therefore, if I put an index, that query doesn't scan, it does a seek, and now the updates can happen and that goes away. One or more of these 3 things will tell you why you have that right now slow problem. It won't fix it for you, and it won't. This may tell you actually the stored procedure or the piece of code inside the stored procedure that is causing the big problem, right? But these things will tell you where you need to go look in large and small scale, right? Every client, always. And if they call me and say, we have a problem, first thing I ask for, give me the results of these. They don't have them, I yell at them. Okay? Go figure those out. Really, really powerful stuff. Third-party products will do that for you. And they'll trend it over history. You can do that too. It's very easy to put these little DMVs into tables in your DBA tools database that every server has a copy of, and trend it yourself if you want. Right? But all third-party products will do actually all three of those things. They don't use who is active, but they do their own version of it. Right? Anybody else?
What can you say about SharePoint?
Nothing that would not get me banned from the city of Stockholm. No, the people that designed it need to be taken out behind the woodshed and thrashed. They were Microsofties. They had SQL Server product team at their disposal. It's a disaster, right? It really is. And remember what I said about legacy stuff, bad design? They're stuck with the bad design of SharePoint 1.0, which was really SharePoint 0.03, I think, when they released it. But it's horrible. And you're stuck with stuff that is just god-awful bad. You really are. And here's the thing. If you don't index some stuff in SharePoint, you got to buy like orders of magnitude bigger hardware than you need if you put the indexes on. But if you put the indexes on, what does that do? You're not supported now. So what do? You script them, you build them, you run great. If you need to patch, you drop them, you patch, you put them back on. If you need to call support, you drop them, you're supported now. My stuff is crazy, we're getting bad data. Okay, well let's take a look, blah, 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 blah. Fix it, get a bug patch or QFE or whatever, put them back on. Right? SharePoint, Navision, oh my God, the dynamic stuff, I never looked at it until like a month ago, and my head almost exploded. Now this was an old copy, right, 2009, but they made so many modifications. This is a huge 500 gigabyte system in Dynamics. They've made so much customizations. Remember the thing you don't touch. They're scared to death to upgrade, and they made a lot of improvements, I found out, in Dynamics up to 2013 R6 or whatever's out now. I don't know, right? A lot of improvements, but they can't get there because they can't test it or make sure it's going to work. It's still, I know it's still, right? Because of the original underpinnings were so bad.
It's in one of the cases where seeks are so much worse than scans, for example, when you have all of the clustered indexes have
yes. It's called something, but the selectivity is like, and it's a char 3 or something like that, right? So that's it, yeah. So really bad. If you're going to build something, get somebody to help you do it right first. Because if you don't, you're going to be the laughing stock of the SharePoint world some 5 years from now. If you make it really big, which you hope you do, everybody in here who builds a product for others, you hope you're the next Google or whatever, right? Or WhatsApp, or you want to be that. But if you start out really bad, sometimes you just can't make it there. And you get one shot typically, right? To go from $40 million a year to 200 million or $1 billion a year. Most companies get one chance. They sell way up market. If they didn't do some stuff right before they implement, last one out, turn out the lights. Yeah.
Let's say there is an expanding business.
Mm-hmm.
They build a new product.
Yep.
There are kind of, let's say, three options. One is store procedures.
Mm-hmm.
One is entity framework. Another
Yep.
is hibernate.
Yep. So you have a product, you're expanding, you're going up market, you want to add some new features, and your options are store procedures or entity framework or in hibernate. Right? So here's a guruism for you. Anything that allows a developer to slap together code is inversely proportional to the performance you will get from that code. Any framework you use that makes you slap together code more quickly, which if you know entity framework how to use it, or in hibernate, you can rock slapping the code together, right? Especially with a GUI that basically writes your code for you. Type a few characters, there's a whole statement, right? That will make your stuff suck. And you can't do anything about it. Nothing. And here's the thing. If you're going to use a framework, I don't care what the framework is, right? ADO.NET is a framework, right? It sits on top of other stuff. Anything you use, read the fine manual. Figure out what the defaults are, what the good things are, how to work around the bad things, set the right things, use all the options it can do. If you don't, you're stuck at the mercy of whatever they did. And some people wrote SharePoint and then wrote entity framework. It's not funny. No, I go cha-ching, cha-ching, right? Read the manual. If you use anything that helps you write code, any object, any framework, any whatever. They all have good things, they all have bad things. Some of them are disastrously bad, right? The default parameterization in varchar parameters. It will crush you, right?
And varchar 255 for everything.
255 for everything. Every column indexed. There's so much bad things you can do, right? But of those three, stored procedures are going to win. But they're not going to let you get to market quickly or quicker than entity framework, right? So remember, most systems have a few things that got to be really fast right now. Entity framework and in Hibernate will let you stored procedure those things. Do that, right? Also know when you don't want stored procedures and you don't want parameterization. Ericsson, mom and pop. If you don't do some things right, you're totally hosed. If you let parameterization do all of its normal good stuff for you, right? Option recompile, dynamic SQL, other stuff. Got to do. Remember though, if you do things right, SQL Server can go wherever you need to go. I promise you. I've seen it do some amazing things. Right? All right, I've worn out my welcome. Thanks a lot for coming and staying. I'll be around. I don't know if we have to leave immediately or whatever, but I'm here till they kick us out or we go have some beer somewhere if they have beer in Stockholm. I don't know. Thanks a lot. I really appreciate it.